All right. We are live. I am going to wait a little while to make sure that people have a chance to get on to the live stream. I hope you guys are having a good day. The weather is so beautiful today. It's so sunny and so nice and warm. All right, it looks like we've got a couple people watching already. If you guys want to introduce yourselves in the comments, that would be great. My name is Betsy, and I work at Impression 5, and I'm super excited to bring you guys episode 1 of our science investigations today. I'm going to go ahead and give everybody a little bit more time to find the live stream and get on before we get started. But while we're waiting for people to get on, I myself have been doing a lot of weird projects while social distancing. So if you guys want to tell me about some things that you guys have been doing while social distancing, that'll be fun. Oh, hi, Izzy. Hi, Avery. Hi, Charles and Lilia. I hope you guys are doing well. Hi, Evan. I'm super excited to have you all here. This is going to be a fun time. So, some weird projects that I've been doing, if you guys are interested, is I've been doing a lot of baking and cooking projects. My roommate and I are building a garden. Um, I've been really thankful for this time a little bit because I've always loved to read a lot, and over the years I've accumulated so many books, but I haven't read all of those books. So I've gotten the chance to kind of go through all my shelves and find the books I haven't read yet, and now I'm getting to read them. So that's pretty exciting. Hi, Griffin. Hi, Callan. Hi, Lisa. You've been letting everybody go outside more often. Hi, Caitlin. Hi, Debbie. I hope you guys are doing well. I really miss seeing all of your guys' faces, but this is what we have to do to stay safe. But it's very nice to get the chance to interact with you guys in this way. Hi, Tilly. Hi, Kim. All right, we'll give everybody a couple more minutes. While we're waiting, I kind of wanted to let you guys know about a possible technical difficulty that we might have. So there is a little bit of lag. You guys have probably already seen it between when you post a comment and when I'm able to see that comment and respond to it. So in order to kind of circumvent that issue, we also have one of my wonderful colleagues here as Impression 5 Science Center in the comments. Their name is Sandy. Can everybody say hi, Sandy? Well, I guess you can't say hi, Sandy, like I just did, but you can definitely type it in the comments and welcome Sandy into this conversation. Hi, Tony. Hi, Emmy. Hi, Michelle. Ooh, I'll go do a fist bump with Izzy. All right, so there is that bit of lag as I was just talking about. So Sandy will be posting in the comments, trying to answer all your questions as they come in because Sandy will have the ability to see them right when they're coming. If your question goes unanswered, it's probably likely that it's something that will get addressed further into the broadcast. However, if we're nearing the end and you've noticed that your question is not getting answered, I will do a general question asking at the very end, and hopefully I'll be able to see most questions that have not been answered that way, and we'll make sure your question gets answered, even if it's not during the live broadcast. I'll be checking the comments in this, so even if you don't have a question right now, or while this broadcast is live, you can always come back. This post will live on the Impression 5 page, and you can always come back and post that question in, and I'll be checking in the next few days to make sure no question gets left unanswered. You guys are doing a great job of saying hi to Sandy. All right, it looks like we've got quite a few people on, so I'm going to go ahead and get started. So, as you guys know, today we are going to be making a compass and learning a little bit about how compasses work. So the materials list was on this caption, and it was also posted in the event page a couple days ago. I'm going to go ahead and share it on the screen. It's going to be kind of floating over here near my face a little bit, and then I'm going to share that image and then also kind of show you guys what materials I'll be using. So I am going to go ahead and put that on there. Janelle, I love this too. All right, here we go. So you should be seeing that materials list now. I'm gonna go ahead and walk through these materials. Okay, so I have a very fancy pedestal here that is made up of board games covered by a towel. So the materials you guys are going to need is some sort of floating material. So this can be plastic, styrofoam, anything lightweight that will float in water. I am using a lid from a tin of baking powder. So I lucked out because this is already in a circle. So if your item is not in a circle yet, go ahead and take some time now to cut that into a circle. It doesn't have to be a perfect circle. If you would like it to be a perfect circle, then you can go ahead and trace something like a cup or a roll of duct tape, something round, and then cut that out and it will be a perfect circle. So I'm using this baking powder lid. It is made out of plastic. All right, next you are going to need a magnet with obvious poles. So here I have a flat disc magnet that looks like this. When we say it needs to have obvious poles, that means it needs to have two obvious sides or ends. And you can test to make sure that your magnet has obvious poles by grabbing another magnet. I have one here in a chip clip and making sure that it shows both attraction and repulsion. That's how you can test that you have a magnet with poles. Now, I know that many people, whoops, let me put it on the side. I know that many people may not have a disc magnet that looks like this or a magnet with very obvious poles just on their refrigerator. So I'm going to give you guys a couple options as to where you can find those. So if you guys have any toy trains at your house that you're not using anymore, any magnetic toy trains that kind of click together, you can definitely get a magnet out of those. However, I don't know how you will be able to put that back together after you pull the magnet out. You can also get them out of chip clips as I've just shown you here. So I very safely took a different chip clip and I wore some swimming goggles to protect my eyes, and I took a hammer and I smashed a chip clip to kind of get the magnet out. You won't be able to get it out perfectly, and that's okay. As you can see, I have a little bit of chip clip still attached to my magnet here, but it'll still work perfectly for what we need it for. And in fact, I'm going to use this so I can prove it to you. All right, next you will also need a bowl. And then this bowl, the only important thing about this bowl is that it has to be larger than your floating material. So you want that floating material to be able to fit inside of this pretty comfortably. You're also going to need some water. I have my water bottle over here that I'm going to pour water from when we need it. And then you're going to need a Sharpie. It doesn't have to be a Sharpie. It can be any writing utensil that will definitely write on that floating material that you've chosen. And then last but not least, you're going to need a piece of duct tape. So I'm going to rip a strip of duct tape that's about 2 inches long. And then I'm going to save that on the edge of my table over here for when I need it. All right. Are you guys ready to get started? Go ahead and give me a thumbs up in the comments if you're ready. I'll wait about 30 seconds. I'm going to go ahead and get the materials. Actually, I'll leave the materials list up for just a moment until I see some thumbs up so that I know you guys are ready to go. Meanwhile, I'm going to clear off, I'm going to clear off my pedestal to just have the materials that I need first. And that's going to be my floating material and my magnet. Got a thumbs up in the comments. Awesome. Oh, hi, Walter. Did I already say hi, Walter? I'm not sure if I responded to that yet. This is so wonderful. I'm so happy to be able to interact with you guys in this way. I feel like I hope my energy is like coming to you guys through the screen. I'm like very high energy right now, but that's how I typically am, so. All right, I am going to go ahead and get started with our first step. Now, I'm going to go ahead and get the materials list off the screen so you guys can see everything that I'm doing. There we go. So the very first thing you need to do is, if you don't have a circular item, as I said before, you want to make sure that this is cut into a circle. It doesn't have to be perfect, but you can make it perfect by tracing a circular object. All right, so next, what we're going to have to do is take our piece of duct tape from before, and you're going to place it onto your floating item so that the sticky side is exposed. So I'm going to do my best to show you guys how this works. This is probably the trickiest part of this whole thing for smaller hands. So if you have an adult or an older sibling or somebody nearby who can help you with this part and you need that help, go ahead and ask for some help. I'll give you guys some time to get this part done. I'll give you guys maybe about 30 seconds. Hopefully the lag isn't affecting anybody too much so far, but please let me know if I need to slow down or if I need to enunciate more or whatever you need from me. I'm very willing to make that change. I'm going to see if anybody said anything about what they're doing while they're social distancing. I did see the one about going outside a little bit more. I didn't see anything else. All right, so by now, hopefully you've put your duct tape onto your floating material. If you are going to make this compass later and you'd like it to be a little bit more permanent, you can always use a different adhesive. I'm using duct tape because I would like to give my baking powder its lid back eventually, but you can always use hot glue or super glue or anything like that. But I'm gonna stick with the duct tape. Do you guys see what I did there? I didn't plan that, but I did plan that. All right, anyway, so next, you're gonna take your magnet and you're gonna stick it onto the duct tape so that the sides of the magnet are exposed like this. So you want both of the poles to be showing and exposed. So you're gonna kind of stand your magnet up onto your floating material. And that is part one. Okay, next up, you're gonna take your bowl and then I am going to start to add my water into the bowl. You don't need a lot of water, you just need to have enough water so that your item here, your contraption, will float in that water. So I'm just gonna pour enough to cover the bottom, and then before I put it away, I'm gonna get a little sip. Okay, so now, at this point, we are almost done. We're gonna test our compass here to see if it works. I'm gonna tell you guys what should happen, and then we're gonna test it and see if it actually does happen. So, what should happen when I place this contraption into the water is that the North Pole, or the north end or side of my magnet, should turn to face geographic north. Now, geographic north, I happen to know, is to my left. So we should see the magnet turn to face that direction. Let's test it and see if it works. I'm going to place it facing you, and we'll see. So almost immediately, you'll see that my magnet is starting to turn. It will overturn a bit, but it will start to correct itself again as it's doing now. So now it's facing north. We did it. But you don't have to take my word for it. You might think I'm lying to you. You might think I'm trying to pull a prank. I don't know why you would ever think that. I'm a very honest person. But in order to prove it to you, I downloaded a simple compass app. And basically, the way this app works on my phone is that you point it in a direction and it uses your GPS, or global positioning system, to tell you what direction you're pointing it in. So for example, I'm going to show you guys. If I point it towards you guys, it's showing that I'm facing the east direction. It might be backwards, but hopefully you guys can still tell that it's pointing east. If I point it in the direction that my magnet is facing, you guys will see that it is in fact facing north. So our compass works. Hip, hip, hooray. Go ahead and dust your shoulders off because we got it to work. And we only have one last step. This is where that writing utensil comes in handy. So I'm going to take my compass out of the water and I'm going to label each side of my compass with the appropriate direction associated with it. So we've got north, east, south, oops, and west, just like that. So now we are officially all done making our compass. Now we get to the fun part. Are you guys ready to understand why our compass works? If you guys need some time to get your compass good to go ahead and let me know that you need more time in the comments. But while we're waiting, if you guys have any predictions as to how a compass can work, go ahead and post your predictions in the comments. I can't wait to read them. I'm going to go ahead and catch up in the comments here. I don't know if I have any puns left in me, to be honest with you guys. We'll see, though. If there's a will, there's a way, right? Let me know if you're following along and you were able to get your compass to work. Ooh, you went on a foot hike to observe nature changes. This is a good time to do that. Spring is springing. I thought you said weast. I might have said weast. It's possible. All right, while you guys are getting your predictions for how compasses are able to work, I'm going to give you guys some background info on compasses in general. So, as we've just seen, a compass is a navigation tool that helps us orient and navigate ourselves here on Earth. Some of the first uses of compasses date all the way back to the Han Dynasty in ancient China. So these first compasses were made using something called lodestone. And lodestone is a naturally occurring, naturally magnetized type of iron ore that's found in the earth. So the ancient Chinese actually found that they could, if they took a thin enough piece of lodestone, almost like a needle, they could dangle that lodestone on a string, and then the needle of the lodestone would eventually turn pretty quickly to face north. Now, I would love to see some of those predictions to see if you guys can explain maybe why that happened. Oh, thank you, Dick. You are being very kind. Does the part of the compass attract to Earth's magnetic field? Ding, 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 Marissa, you're right on it. So the compass actually only works because of Earth's magnetic field. But to understand how it's able to work, we kind of have to take a step back and first look at the composition of the Earth itself. So that's what we're going to do. You guys may know that the Earth is made up of several different layers. If you know any of those layers of Earth, go ahead and post those in the comments. And then I'm going to show you guys a diagram that kind of labels each different layer of the Earth. And we'll kind of go into the composition of each layer and how each of those actually helps or produces the Earth's magnetic field. It doesn't help it. All right. While we're waiting, do you guys want to hear some magnet facts? I have a couple. So, my first magnet fact is that birds are actually able to see the Earth's magnetic field. They have special molecules in their eyes that allow them to see it, and they can use it to navigate. So that's how they're always able to fly south for the winter. Is there a reaction between the magnet and the water? My magnet is not actually touching the water, so I'm not seeing a reaction, and there should not be a reaction. We've got the crust, the mantle, the outer core, the inner core. You guys are great. You got it. So I'm going to go ahead and share that image with you guys now. In order to do so, I'm going to have to turn off the camera. But I just wanted to give you guys that warning because the screen will go black, but your connection isn't messed up. I just had to turn off my camera to show you guys the image. Here we go. All right. So here, oh no. Here we have an image of the different layers of the Earth. In the comments, I saw Janelle mention the crust and the mantle, the outer core and the inner core. I see Mindy giving us the crust and the core as well. We are on it. All right, so as you guys can see here, we have several different layers of Earth. So first we are going to start all the way on the inside with the inner core. As you can see labeled on this diagram, the inner core, is a solid. I'm sorry, I didn't mean to accidentally scratch it out, but hopefully you guys can still see that it is solid. It is made out of very, very densely packed iron, and it is also incredibly hot. So the next thing I want you guys to put in the comments is your guesses for how hot you think the inner core is. It can be as low as you think or as high as you think. I'm going to tell you the answer no matter what, but I want you to know that it is incredibly hot there in the inner core. But other than the inner core, we have, while you guys are getting your guesses in, we have the inner core, the outer core, the lower mantle, the upper mantle, and the crust. The crust actually has a couple different layers of earth as well, or I'm sorry, just layers in general as well. It has the asthenosphere and the lithosphere. Those are not represented in this diagram, but they are there. But that's okay that they're not represented in this diagram because we are going to be focusing really on these very innermost ones for our explanation here. Let me catch up to see if we have any predictions. Ooh, 9,800 degrees Fahrenheit, 10 million degrees, 50,000, 1 billion.9. I like the precision there. What's my favorite color? My favorite color is purple. It has always been purple. It has never changed. 100, Tilly says. So actually, the inner core rings in. Can I get a drum roll, please? It rings in at 10,300 degrees Fahrenheit or 5,700 degrees Celsius. So that's incredibly hot. It's actually just as hot as the surface of the sun. So now we know that, and we know that the surface of the sun is so hot. And so we can use that information to also know that the inner core is also incredibly hot. So with that being said, it's very, very, very hot here in the inner core, as I've just repeated to you several times. But it is still a solid here because their surrounding pressure is so high that the iron that makes up this inner core is very, very densely packed together. So it's not able to move freely, and therefore it is solid. Next, we have the outer core, as you can see, is labeled here as a liquid. So the outer core is made up of mostly iron, just like the inner core, but it's molten iron in this case. So it is a liquid. And there's also some other molten metals like nickel inside of this area as well. So here in the outer core, something very interesting happens. The liquid in this outer core is able to heat up because of its proximity or its closeness to the inner core. So as liquids heat up, what happens is the particles inside get really, really, really hot, and the liquid starts to expand because those particles are trying to get as far away from each other as possible. So for example, if you are standing in a crowd on a very, very, very hot day, that would probably not be something you would want to do. On a hot day, I like to be as far away from other people as possible so that I don't have to be sweaty around other sweaty people. So the particles kind of act in the same way. They want to get as far away from each other as possible. So the liquid starts to expand because they're able to do that. So as this liquid here, closest to the inner core, starts to heat up and expand, it also starts to rise upwards, further into the outer core. Now, this poses an issue because there is already liquid here. There is cooler liquid here. So what happens is that hot liquid that just rose up actually displaces that liquid that was there before, and now it has nowhere to go but down. So what happens is that cooler liquid up at the top sinks down due to gravity closer to the inner core, and this cycle continues over and over and over again. This movement and heat transfer cycle is called a convection current. Oh, I just saw your comment, Aiden. Hi, Aiden. Thank you for loving the video. So these convection currents, I'm going to share a different image with you guys right now. These convection currents, as you will see in this next image, is that they are happening all throughout the mantle and all throughout the outer core. So part one of our explanation is done now. We still have a little bit to go, but I want to check in with you guys and make sure that you are understanding everything up to this point. So please, if you have a question about this, please post it in the comments so that either myself or Sandy can answer that for you. But we have officially made it through most of our explanation here. And you guys are doing great. You guys should be really proud of yourselves. This is some pretty advanced stuff to understand, and you guys are killing it. Thanks, Taylor. Candace, I'm really happy you guys are enjoying this. And purple is the best. I very much agree with that. I'm not seeing any questions come in yet. It could be because of the lag, but that's okay. While I wait, I'm going to give you guys a little bit more time to post those questions. But while we're waiting, I can give you guys some other magnet facts if you guys are interested. So magnets only attract certain types of other metals. So materials such as glass, plastic, or wood aren't attracted, but those types of metals that magnets are able to attract are iron, nickel, and cobalt. So if you have a magnet at home and you also have a penny that's made out of copper, the penny is not going to be attracted to your magnet. It is a little confusing. So is there any point where you are the most confused? Is there anything specifically that I can clarify for you? Emmy loves anything purple. Me too. So I'm just going to explain the convection currents a little bit more. So basically what's happening is there are all these layers of Earth that are liquid. And this liquid that's closest to the hottest part of the layers of Earth, the inner core, starts to heat up because of how hot the inner core is. As it heats up, it starts to expand and rise up further into the outer core, where it runs into some other liquid that it takes the place of. And now that other liquid then sinks down closer to where the inner core is, and that cycle repeats itself over and over again, and that is a convection current. I did go to MSU. All right, we are going to go ahead and move on to the next part. This cycle of convection currents actually continues itself in a self-sustaining loop called the geodynamo. This constant flow of the liquid iron that we're seeing here generates electric currents, which then in turn generate and produce magnetic fields. So we finally made it to the magnetic fields part of this. So each of these convection currents that we're seeing actually produces its own magnetic field, but all of these magnetic fields are roughly aligned in the same direction. So the combined effect of all of these magnetic fields adds up to one enormous magnetic field that surrounds the entire planet. So I'm going to go ahead and show you guys another image, number 3, that shows this magnetic field. As you guys can see, because of this magnetic field, all these magnetic fields aligning in the same direction, you can almost pretend that there is an imaginary bar magnet deep within the Earth's surface, with its south pole or south end at the geographic North Pole, and the magnetic north end at the geographic South Pole. Now, I know this sounds super backwards, but it is all due to the opposites attract rule of magnets. So if you guys remember, all the way back to when I was showing you guys the materials that we have, we talked a little bit about attraction and repulsion. And when we tested our magnet, the way we knew it worked was because the North Pole, or the north end of the magnet, was attracted and turned to the north direction because it was attracted to the south end of the magnetic field that exists up in the northern part of our Earth. I know that that's super confusing and it does sound a little bit backwards. So I'm going to ask you guys, is there anything about that that I can clarify? The magnet is flipped to what we would think it is. So, because of the way our magnetic poles and our magnetic field is aligned. Sandy's favorite color is gray. All right, so because our compass is able to work because the north end of our magnet is attracted to the magnetic South Pole, which is at the geographic North Pole. What is a magnetic force? So, Lilia, this is a little bit of a complicated question, so I'm going to do my best job explaining it to you. So, a magnetic force is anything basically that will attract or repel, but it only attracts or repels because of the particles inside of it. So, I'll show you guys. I'm going to go back to my camera so you guys can see me. All right, so I'm going to show you guys this with one of my magnets here. Basically, we were talking about the two sides of a magnet. We have one pole here, one end here, and one pole or one end on this side. The magnetic force is attraction or repulsion that occurs because of the way the electrons or the particles inside of this magnet spin. So the opposite sides of a magnet have electrons that spin in the opposite directions, which is what creates that magnetic force, that attraction versus repulsion that we see in a magnet. I hope that answered your question. All right, so we are officially to the very end of our explanation. So please, if you have any questions, put those in the comments. Even if we don't make it to answering those questions today, I will definitely be checking the comments in the next couple of days to make sure all those questions are answered. If you guys were able to make your compass along with me today, please share your creations. We would really love to see them. I'm going to go ahead and show you guys some directions for sharing those on the screen. So I'm going to go away for a moment again. So we have a couple different ways you can share those. You can either tag the hashtag MyImpression5 on social media. You can email us at zeller@impression5.org, or you can text us at 517-515-3782. So I'm going to also post this along with the materials list in the comments after this broadcast is over. So please let me know if you guys require any other information. But other than that, we are officially all done. We are going to post some links in the comments for other resources that talk about magnets and compasses as well, so you guys can extend your learning a little bit if you choose to. But other than that, I am officially first going to check the comments to make sure I didn't miss any questions. And then it doesn't look like I have, but I'm officially going to sign off. Thank you guys so much for joining us for our inaugural science investigation here on the Impression 5 Facebook page. And make sure to tune in next week to learn about cacti with Julie. All right. Bye, everybody. Thank you guys so much.